My name is Natra binti Syarif. My matrix number is CD210096. So today I will present to you guys about introduction, problem statement, and objective. For introduction, computer programming is an objective-oriented programming language that offers programs a clear structure and enables code reuse, which reduces development costs. We must first comprehend traditional machine and their operation in any company before proposing a tree design that can be completed by a single machine using lathe, milling, and drilling machine. Furthermore, each program must contain at least two functions, two for looping, deletion operation, and array. And each program must contain at least 5 operational stages to complete a part machining. Okay, next, the problem statement. The problem statement is we need to help the company improve their production, planning and development. 3 programs to guide the operator in using conventional machine for selected metal part in lathe, milling and drilling machine. By 1 program for 1 machine type with 1 part design based on the suggestion step. Okay, we move to the objective. So the objective is operating traditional machine present a number of difficulties, including estimating part, machining time, total energy consumption, total operating cost, byproduct or solid waste formation, and expected daily productivity. Thank you.
Hi, today I want to present about the machine specification. For drilling, type of drill machine is a pillar drill, and the machine BMT is 20 hours. Our drilling machine have a drilling speed at 12,000 revolution per minute, and type of cutting tools are quoted high speed steel. We use high speed steel, and the cutting speed is 14,000 mm per minute. Next, our product is milling. Type of milling machine is a metal milling machine SP2113, and machine operated per day is 8 hours. Material types we use aluminium rod, and rotation speed is for 400 revolution per minute, and our cutting speed is 62.83 mm per minute. Cutting teeth number is 4 use, and the chip load is 0.1 meter. Next is our machine. Product is a lathe machine. Type of lathe machine is a metal lathe machine SP2113. Machine operated per day is 8 hours. Material type we use aluminum rod, and rotation speed 400 revolution per minute, and the feed is 0.12 mm per revolution, and our cutting speed is 62.83 millimeter. Cutting force is 3,100 Newton. Next, this is our part of design. Our drilling product we use a door hinge, and milling product is a gear, and the lathe product we produce shaft. For the overall process, members suggest a product, then we discuss the idea meeting, and we decide is it good idea. If no, our team is to reject the idea. Some of us team member conduct more research because it's not enough of info, and we team member, if yes, the team member further defines the project. Then our team member write the proposal, and we check the proposal, is it okay or not. If not, the team member revise and redo the proposal. Then if yes, team member that make a coding that report, and then end our project.
Okay, next I would like to present about the schedule. First is about drilling. First step is start drilling process, then clarify machine specification, and then type of machine that we use is pillar drill machine BMT 20H. Drilling speed is 12,000 rotation per minute. Type of cutting tool, called high-speed steel. Cutting speed is 14,000 mm per minute. Input outputs or default parameters. First, diameter is 3 mm, depth is 1 to 5 mm, and total hole is 8. Result for product, material removed, processing time, material efficiency, energy use, and lastly is end drilling process. Okay, next, what about mining? First step is start mining process, then verify machine specification. Type of machine that we use is metal milling machine SP2113. Daily operation hour is 8 hours per day. Material type that we use is aluminum rod. Rotational speed is 400 rev per minute. Cutting speed is 22.8 mm per minute. Cutting feed is 4. Chip load is 0.1 mm. Input allowable or default parameter. Inlet diameter is 10 mm. Wide is 15 mm. Number of feet is 9. Anything facing parameter is length is 10 mm. Height of feet is 10 mm. Wide feet is 5 mm. Then start looping process for 4 times. Result for product, machining time, estimate productivity, solid waste, volumetric rate, energy consumption, and end milling process. Okay, last but not least is about lathe process. First step is start turning process, then verify machine specification, then type of machine that we use is metal lathe machine SP2113. Machine operate per day is 8 hours per day. Method type is aluminum rod. Rotational speed is 400 rev per minute. Speed is 0.12 mm per minute. Cutting speed is 22.83 meter per minute. Cutting force is 3,100 Newton. Input, output, or default parameter. In this project, we have 8 parts. For product A, diameter is 100 mm, length 40 mm, and a new diameter is 35 mm. Product B is diameter 100 mm, length 30 mm, new diameter is 30 mm. Product C, diameter is 100 mm, length is 20 mm, new diameter is 35 mm. Product D, length is 25 mm, new diameter is 30 mm. Product D is length 25 mm, new diameter is 25 mm. Product A is diameter 100 mm, length is 20 mm, and new diameter is 40 mm. Product G, diameter is 100 mm, length 10 mm, new diameter is 70 mm. And last part is product S, diameter is 100 mm, length 5 mm, new diameter is 45 mm. Result for product A, B, C, D, F, and G. Machining time, estimate productivity per hour, solid waste, energy consumption, and end turning process.
Okay, now I would like to present about the flowchart for our machine project. First, this is a flowchart for the milling product is gear. Based on this flowchart, we tell from beginning of the product until the end, until the get a products. So we start. After that, we know about the milling machine informations. Next, display milling machine project. Put plate on the machines, and then enter the value below and define the parameters. After that, if the thickness is less than the formula diameters, so we have to put the input.
the number of the T with the T and the hide the T. Next, we get display the time, the value, and then output. So time over 2080, and then display outputs, display the material efficiency, and end. Okay, next this is a flow chart for the daily products. This is okay, we start and then we have to know the information and then we insert. After that, if we have the problem, we go back to the information and then we insert again. So then we have to doing the whole. After that, we have to get the diameter. We have to get the diameter and the diameter tool less than the DL, and then we have to do the diameters. Diameters is less than the depth, and then we have to calculate some the formula and for the rotations, fit the speed, process time, volume, material removed rate, power, and then we calculate the power until we get the percent of the material efficiency, and then we display the process time, display the material removed, display the material removed rate, display the material efficiency, and display the energy using, and then end. And last, this is a flow chart for the late product is shaft. Okay, this flow chart we tell everything from the start until the end process. Okay. Okay, first we have to know the informations, and then we load and define the parameter. After that, we do a product A until product H. After that, we get the result from the from the product A until the product H, and then we display the value. After we get the result, we display the value, and then we display the time value, and display the time value. After that, we do the scrub generate, and then we, if the product is have any problem, we try again to do we try again to the allow the define the parameter, and then we start from product A until product H, and then we get the result A until the result the H. Next, we display the scrub generate, and then output time over the 1800, and then display the outputs, display the material efficiency, and then end. That's all from me.
Hi, now I want to explain about the program code and calculation. Okay, now I want to explain about the C code. The first one is C code for milling. Okay, what we can type at the C code is starting milling process. Other than that, we can clarify machine specification. For example, type of machine, daily operation, material type, rotational speed, cutting speed, and anything else. So after we run the C code, we can get the answer. For what we can see at the black screen is this is a result after we run the code programming. Okay, next C code is drilling. So the C code same like the milling process. Okay, the first thing is we list the input. For example, the first one is we type as a start drilling process. After then, we can type the clarify machine specific, and then the type of machine, drilling speed, type of cutting tool, their diameter, hole, and so on. So after we run the C code for drilling, and we get the answer like the at the screen black screen. So after we run, this is the result. Okay, lastly, this is a C code for lathe machine. So our group plan to do a shaft from the lathe machine. Okay, now what we can see, this is information what we use to do a shaft. We key in the data for cutting speed, their diameter, their length. So after we run the C code, we get the result that is specific for the our product. Now I want to explain about the operation analysis milling. Okay, in variable we can put 5 types. The first one is part machine time. The second one is total energy consumption. The third one is total operation cost. The fourth is byproduct or waste generation. And the last one is estimate product per day. Okay. The first point is part machine time. What we can list at this part is the rotation speed, right, 400 revolution per minute, and the feed is 0.12 millimeter per revolution. Cutting speed is 62.83 meter per millimeter, and last one is cutting force 3100 Newton. That machining time of to make a gear. Next, the total energy consumption. Okay, so the power consumption, the final answer we get is 3.75 kilojoule per product. That for energy consumption. Okay, the third one is total operation cost. Operation cost, the last cost is 45 cents. And by product or waste generation, the answer for volume of the raw material is 120,000 millimeter per cube. And mass by product is 0.15 kilogram. Okay, the last one is the estimate productivity per day. So we can make the product 6,840.3 kilogram per day for the milling process. Okay, next, operation analysis drilling. The process is same like the milling process. So in part machine time, we can include the assumed cutting speed like 14 meter per minute, and feed rate is 0.4 millimeter per revolution. Depth of cut is not to excess 1.5 millimeter, and drilling speed is 12,000 RPM. So total machine time is 12.5 seconds per product. That's for the part machine time. Next, the total energy consumption. The first operation, the power consumption, we get the 88.3 kilowatt, and energy consumption, we get 8.83 kilojoule per product. Next, the total operation, we get the operation cost. The cost is 56 cents per unit.
And the fourth is byproduct or weight generation. The volume of the raw material is 120 millimeter per cube, same like milling, and the mass of product is 0.15 kilogram. And the last one is estimate productive per day. The mass of product is 0.2231 kilogram, and the productivity per day is 1552.1 kilogram. Okay, the last one is operation analysis rate. Okay, for machine time, we assume cutting speed is 60 meter per minute and feed rate is 0.4 millimeter per revolution. Depth of cut is not to exceed 3 millimeter. So the total machine time is 12.5 seconds per product. Okay, for the energy consumption, the final answer for power consumption is 4.39 kilowatt. Okay, uh, the energy consumption is 0.3 kilojoule per product. So the total operation, the final answer for operation cost is 56 cents per unit for our product. And byproduct or weight generation, mass of byproduct is 46.63 gram. And the last part is estimate productivity per day. So the mass of product is 0.2231 kilogram, and the productivity per day is 1552.1 kilogram. That's all for our presentation. Thank you.